So welcome to Unit 8. In Unit 8, we're going to be studying lines. And one of the main qualities we need to know about a line is its slope. But before we get to that, we're going to do slope of ramps, right? So I want you to just look at these ramps and tell me which one you think will make the motorcyclist jump higher. It could be a bike or a skateboard, it doesn't matter for our purposes here. Now, I think if you look at one, I think most people will pick A, right? Now let's look at the two ramps. They have the same exact length on the bottom, but they're different heights, right? And so if you go up this ramp, you sort of jump like that, and this ramp you jump like that. Remember, we're not looking for longer, we're looking for higher. So I think the higher ramp clearly will make you jump higher in any case. Now over on the second one, they're both the same height. But one is really, really long and one is really, really short. Which one do you think you might jump higher with this? Well, I think you might pick B, and the reason is this. This, you would sort of do that, right? Now, assuming you can get up the ramp, you get enough speed to get up the ramp, you get a little hop here, right? The angle there would pop you up in the air, and so I think B would be the correct answer. Now, what we're really looking at, though, is that both of these numbers are important to understand this ramp. Both the height, all right, which we're going to call the rise, although we'll talk more about why it's not exactly the height, but how much this ramp goes up is important, and how much this distance on the bottom is also turns out to be important, and that's called the run. All right, so we're going to be finding something called slope. The slope of this top ramp is literally you take this distance, this dimension here, and you put it in the numerator. You take this dimension in the denominator and you make a ratio out of them, and we say the slope of that ramp is 7/8. And so the ramp on the bottom is described as 3/8. And notice that 7/8 is bigger, right, than 3/8. And the ramp with the bigger number makes you jump higher, all right? There's limits to that, but it's the ramp that is going to point more up. Okay, so lots of vocabulary as usual in lesson 1. So the slope is called the rise. The way you say that is rise over run. So you will hear this again and again from other teachers. The slope is the rise over the run, or rise over run. So to find the slope of this first ramp, the rise is here, it's 2, it's how much, and notice, please, when you take your notes, the rise has a direction. That's why I was saying it's not just the length. It has a direction, and its direction is up. All right, so the rise, it goes up 2, and that goes in the numerator. The run also has a direction. It goes this way. There's an arrow there, and this is called the run. And so the slope is the rise over the run, in this case, 2/7. Yes, it's that easy. All right, so what's the slope here? It rises up 8. That goes in the numerator. The run along the ground is 5, and it's 8/5. Do not make it 1 3/5, all right, because that hides the slope. It doesn't help us, and some of your teachers told you to always make these into mixed numbers. That's not a thing. It's not a rule. All right, they would try and get you to practice making improper fractions into mixed numbers. But we're going to be leaving 8/5 as 8/5. So what's the slope of that? Well, it rises up 2 and it runs 1, but we're not going to leave it that way because that needs to be simplified, right? Going from 8/5 to 1 3/5 is making a mixed number. It's not simplifying. Going from 2 over 1 to 2 is simplifying. Fractions need to be simplified. All right, so we're going to find the slope of this first one, and it has a rise. It rises up 2, and it has a run of 6, and you'd think the slope is 2/6, but the problem is you always simplify your fractions. And so it actually has a slope of 1/3. Now, as we look at this, look what I just drew there. I just drew a little ramp inside our ramp, and that ramp has a rise of 1 and a run of 3. A rise of 1 and a 1 of 3. And notice the ramp that was 2 over 6 and the ramp that is 1 over 3 perfectly line up. And why is that? Because they have the same slope. The slope is trying to tell you, put a number on, tell you what the tilt of that ramp is. The bigger the number, you know, these are fractions, but the bigger the number, the more that arrow points toward the ceiling, toward the sky. All right, the lower the number, the more flat the ramp is, the less high you will jump. Okay? All right, so what's the slope of that one? Well, looks like it's 4/12, but 4/12 needs to be simplified. And look at that, I get 1/3 again. So let's look what we can do with that. All right, there's the ramp that was 2/6. There's the ramp that was 1/3. Notice they all end up having the same slope 1/3, and they all line up. Wait, the one that's 4/12 is bigger, but the tilt of the ramp, the slope of the ramp is the same for all three. Let's do that again. All right, so this one looks like it has a slope of 9/6, but 9/6 needs to be simplified, and you get 3/2. So once again, there's the rise of 3, a run of 2, and there is the tilt of that, or slope of that ramp. 18/12, yes, that also simplifies to 3/2. So the one with 9/6 and the one with 3/2 all line up, right? And for those who are skateboarders, you're looking at that ramp going, that ramp is too steep. It has too high a slope, right? It would be hard to push a skateboard up there and get any height out of that because it has too high a slope. Yeah, it turns out that like the magic, right now, skateboard ramps are curved now, but when they were straight like this, a 45-degree angle is really the key to having the maximum that you are going to jump on a jump ramp. And so here it is. So here is the slope of 6/6. So what's the slope of 6/6? 1. This is a slope of 1. And a slope of 1 is, you know, once you get over slopes of 1, the ramps get too steep, okay, for jumping. But at a 45-degree angle, that's what this is, right? A 90 would be all the way. Halfway to 90 is 45. And so this is a slope of 1. All right, so what's the slope there? Right, 9/9, still, right, still the same as 6/6, still 1. This second one is bigger, but it has the same exact slope, 1 whole. So ones that are lower have fraction slopes, less than 1. Ones that go more toward the sky have higher slopes than 1, like 5/4 is bigger than 1, and 3/2, right? That's up here. They're larger than 1. Oh, and there's the slope of 6/6. All right, now, you can go from 0 to infinity. You also can go negative, but that's another day. So perfectly flat, right? This is perfectly flat. The rise, remember, the rise is how much it goes up. It goes up 0. It goes along 5. It doesn't matter what that number is. That's a slope of 0, right? Flat is a slope of 0. So is that also a slope of 0? Yes. Right? You would jump how much? Not at all. 0. Now what's this slope? This slope is 24/1 or 24, right? That's almost a wall. Okay? That's almost a wall. Right? This is like the floor. The floor, hopefully your house has a slope of 0. In other words, it's flat. It's not tilted. The walls of your house have a very interesting slope you'll see in a second, but 24 is a huge slope, right? Normally we're using fractions, both right? Fractions and regular proper fractions here, improper fractions and whole numbers up there. All right, so what is the slope of your wall? Turns out it's undefined, and it's because you can't, the run here is 0, right? That's not allowed. That is undefined. Not just today, anytime you have 0 in the denominator, your fraction is undefined. So slopes of walls are always undefined. The floor has a slope of 0. Your walls in your house, if they're straight up and down, which you hope, have an undefined slope. Undefined means we have no definition, no answer in math. All right, if you have steps in your house, they have a slope, right? We can picture this as similar to the ramp. And it turns out this part of a stair is called the riser. And this flat part of a stair is called the runner. It's from slope. So the slope of those stairs are 9/12, but you always have to simplify. And so the slope of those stairs is 3/4. And if you have a parent who is in the construction trades, different stairs have different slopes, and there are good ratios for stairs and bad ones. Think about this. Think about if you had stairs in your house with a really high slope, right? That would not be good, okay? But also think about garden steps. When you've ever been to a garden and you've had awkward steps like this with really low slopes, yes. So the slope of your stairs is very important. The roof of your house in anywhere that has snow is usually not 0. In California, where we are, when I'm doing this, we have a lot of flat roofs because we don't have snow. We have roofs with a slope of 0, okay? But here, now there's an extra number intentionally, right? We don't need that. The rise is 12 here. The run is 9, and you don't need this side of it. So it's 12/9. And you simplify your fraction, and this roof has a slope of 4/3. So let's practice. All right, so this one is 3/14. What do we call the top number? The rise. What do we call the bottom number? The run. And when we put it together, we call it the slope. The slope here is 12/4, so you would never leave it that way, and you don't leave it 3/1. You say the slope here is 3. Here the slope is 6/14, but those are even numbers, so they can't possibly be the right answer. Yes, the slope of those stairs is 3/7. This is not to scale, but there's someone going up a mountain, and right there's the rise of this mountain, 5. There's the run, 15. We would simplify that, and we get 1/3. And what do we call it when we ski down a mountain? We ski down the slope, all right? It's a ski slope. Again, it's from this. Oh, I just gave you this answer. What's the slope of this roof? The slope of that roof is 0. Hopefully like the slope of the floor in your house. All right, good luck with the homework.